Audio coming through okay?
Yep, we're rolling.
Okay. All right, I guess we'll go ahead and get started. Apologies, this is a little bit markety. I've used this presentation some other places, so just bear with me on that. Basically, we're going to look at Red Hat's identity management today and how that can simplify using Active Directory identities on Linux machines. So, I'm Roy Williams. I'm Red Hat certified engineer. I've been with Red Hat almost 3 years now. Been doing Red Hat products and identity management for several years now, and helping develop some solutions for IDM around smart card and things like that. Just different solutions that we can go out and deliver to customers. And then this is my friend Chris Malafis, who usually does this presentation with me. Unfortunately, he wasn't able to come in, but that's him. You can see us on YouTube doing something similar to this. So today I want to go over just the different components of IDM, different trust methods that we have available, and that would be your Active Directory trust, so trusting for identities and authentication, how we manage users and groups, the architectural design, and some discussion on how the authentication works, and then we're going to briefly touch on some generalized field studies. Objectives out of this are going to be understanding the fundamentals of the different integration methods, so the different ways we can integrate with Active Directory, and identifying which method is best based on your situation. So, what is IDM? IDM, or free IPA, as you may see it in the community. Free IPA is the upstream of what we market as RHEL IDM, is a centralized way to manage authentication, authorization, and policy. So think your Windows Active Directory domain controller. This is analogous to that on the Linux side. So as it says here, without IDM, of course, typically all your systems are managed individually, unless you're using LDAP or something of that nature to manage your users. But even if you're doing that, a lot of times you're still managing all your sudo policies on a server-by-server basis, and your host-based access control is all in a SSH config on each server. This really allows us to simplify that in a single location. So the advanced features would be the host-based access control, sudoers, and we can also do file shares for home directories, so you can auto-mount your home directories. You can define all of that in a single location, much like Active Directory. The other big benefit here is it's all native tooling, and we can still integrate with Active Directory. So there's no third-party products that are going to break every time you run a yum update. It's all native stuff that's already there. So the benefits, your IT administrators will be able to maintain identities in one place, so you're not having to go to every single server to update a password or lock a user that left. We're able to apply policies to multiple machines at one time, so we find that we have an issue with a sudo rule. We can go out and immediately modify that sudo rule across the board instead of doing it in every single system that user or that group is associated with. We can set different access levels. So one of my favorite examples for that scenario is you have a group for your admins, and you give them access to everything with sudo, and then you have your developers, you give them access only to development servers, and you don't give them sudo, or maybe you give them sudo to run one or two commands. That's very easy to define in IDM. Again, the centrally managed privilege escalation, that would be or sudo policies, and then the easily integrating with Windows Active Directory. That's done with a trust, basically just like setting up a new Active Directory domain and trusting it to an existing one. The user interface for it is a web UI. There's also a command line interface and an API, so there's multiple ways that you can interact with the service. And the UI is very nice, rich UI that's pretty simple. It's not something super complicated. You can basically sit down and find things as you're working through a problem. It allows for increased work or productivity. Just because you're not having to go all over the place to manage several different things, you're able to do everything in one place. And of course, decreases cost because you're freeing up your resources. So the components we have for IDM, we have our servers and we have our clients. Pretty simple. So for servers, sometimes you'll see references to master and replica, but realistically, everything is a multi-master replication. So the way that boils down is you have the initial one that you built and then you make replicas off of it, but at any time any of those others can take over as the master if you need them to. The servers also act as the central repository for all your users, unless you're pulling all your users from Active Directory, and it's also the central repository for all your policy-based controls, so your host-based access control, sudo, etc. Our clients obviously are just any Linux machine. This isn't just a RHEL thing or a CentOS or Fedora. There's also SSSD packages, which is the client-side software for Ubuntu and other Debian-based distros. And then beyond that, Unix-based operating systems can benefit from this as well by just integrating with LDAP and Kerberos. There may be some limited functionality there, but you'll still be able to make use of the identities and some of the single sign-on capabilities. So our IDM server has several pieces to it. We've got DogTag CA. It's a small CA. It's not a full-blown CA like Red Hat certificate system. We've got Kerberos KDC, which takes care of our single sign-on. We're running Bind to take care of our DNS, much like Active Directory does when you join a new computer to it. And we also can do NTP from here. So if you have a Stratum 1, you can point the IDM servers at your Stratum 1 device, and then they'll pre-populate all of your NTP settings. And then we manage this again through web UI and command line tools. And there's also the API that's available. But this is really nice because if you need to make a quick change, web UI, super clean and easy to use. If you have a bunch of changes you need to make, you can easily script it out with the command line utilities. The clients, there's no dedicated software, like there's no third-party software you got to go out and get. Everything is in the base RHEL repo, or if we're talking CentOS, it's in the base OS repo. Same for Fedora. I think that may even be the case for Ubuntu, but don't quote me on that. And basically, the package that we use is SSSD. That's the actual client software. There's another package, IPA client, which is basically a package group that puts SSSD and other things on there. And that IPA client installer that gets installed with that will set up SSSD for you. The only real requirements we have to set up a client is good DNS, good time, and that's really it. DNS and time synchronization are crucially important for Kerberos. If it can't resolve the hostname correctly, or it can't, or the time's skewed, then the Kerberos tickets won't line up and authentication won't occur. So the client-server relationship, again, this is pretty simple. So we still have our IDM server over here, and then for our client, we have the SSSD client that talks to our IDM servers for LDAP and Kerberos, and then we also have CertMonger that will come over, and that's what that's going to do is it's going to pull in our CA cert so that your certs for your browser, if you need to go to the administrative UI or something, are all valid. And then we can also assign out other certificates to the systems if we need to and manage those with CertMonger. So the different integration methods we have. First of all, why do we want to use Active Directory? Why do we want to integrate? A lot of our customers come to us, they've, for a long time had a big Windows footprint because they use Windows workstations. It happens, it's pretty much everywhere. And everybody wants to use those IDs that they're already familiar with, the same usernames, passwords, etc. And there's been lots of ways that we've been able to do this in the past. Some of them are good, some of them have been kind of not so good. And we feel that this is, well, what we're going to go over is probably two of the best methods to do this. And really the way to choose between the two is strictly based on the size of your environment and how much you expect it to grow. So integrating with Active Directory allows us to, again, focus on managing one set of identities instead of managing users for both Windows and Linux. The cost savings we talked about, that's just because we're freeing up our time and resources. There's less passwords to remember, which means less password resets for everybody that does help desk, and easier auditing because we got one place to go see who logged in where, when, and it allows us to use those users that we already have. So our two methods of integration are direct and indirect. A direct integration means that we're directly connecting our Linux system to Active Directory. So for anything that has SSSD, so we're talking RHEL, we're talking CentOS, Fedora, Ubuntu, we can directly connect that to Active Directory by using SSSD. For RHEL variants, we have this thing called realmd. It's a wrapper that basically assists with the setup and configuration of SSSD so that it really streamlines the process of connecting to Active Directory. The indirect integration is where we start talking about using identity management, or IDM, as a middleman between our Linux clients and Active Directory. So why one or the other? The direct integration is a lot simpler if you just have a couple of systems. You just go out, set up some config files, you're done. But it's hard to scale. If you got a large environment, it's kind of painful to go out and deploy a config file everywhere and hope that there's no variants and things, and it becomes a nightmare to manage. There's certainly some tools that help with that, but we're setting things up this way. You're more or less doing a trust between each individual system and Active Directory, and there's performance hits, and just trying to manage it doesn't really work out well at large scale. So that's why we want to go with indirect if we have a large environment, or even if you just want to have some extra tools like managing your sudo rules all in one place. So for more complex setups or large environments, that's why we want to use indirect. If managing sudo policies and host-based access control rules are important, then we probably want to go with indirect even if we have a small environment. So SSSD integration, again, this directly connects us to Active Directory, each individual system. All the users live in Active Directory, which is to be expected at this point. And we can do some host-based access control with group policy. It's not great, but it's there. It takes some customization to make it happen, but it can be done. There's no additional hardware or software to maintain, so you're not building any additional infrastructure when you're doing this. So that's why it's a little bit simpler. And again, it's a simple solution for small offices. If all you need is your users to be available to log into those systems, this is probably the easiest thing to do. And for anybody who's interested in smart card authentication, you can support smart cards on this with RHEL 7.3 or newer. And the best part about all of it, it's all free open source software. So it's stuff that's already there with the OS, stuff that's upstream, downstream, everywhere. You don't have to even buy Red Hat Enterprise Linux. You can use CentOS, Fedora, whatever, it's there. The requirements, you have to have knowledge of the Active Directory environment, obviously. If you're going to connect to it, you have to know how to connect to it. You have to know what server to point to. You have to have domain administrator privilege. That way you can join to the Active Directory domain. And one big caveat, if you're using NTLM, then this isn't going to work. NTLM is, been dead for a while, but some places it still is in use. if that is a requirement, there are other ways like WinBind that will work for that, but SSSD does not support NTLM. So Realm D, or Realm D join. Again, this is a wrapper that we use to set up SSSD. It will also set up WinBind, so in those edge cases where we have to work around NTLM. Yeah, so this is the wrapper script that allows us to easily set up the direct integration using either of those clients. And what it does is it helps discover the identity domains and helps configure the client software instead of you having to go out and manually edit the configuration files yourself. All right, so into the indirect or cross-force trust. So the trust is all based on Kerberos. Kerberos allows us to have that single sign-on, and basically when we authenticate, we get a Kerberos ticket that says, hey, this person is who they say they are, and they have access to things. And then that ticket, what we're doing is trusting where that ticket originated from so that it will also be valid and accepted on our systems. And this is not restricted to trusting a single AD forest. And we'll talk about transitive trust here in just a minute. There's two main components to doing this trust. We have what's called a trust agent and a trust controller. An IDM server, any IDM server can be a trust controller or a trust agent, and we have to have at least one trust controller to talk to Active Directory. The reason for this is the trust controller is able to resolve the users and groups. It's able to enroll clients, but also it's able to manage the trust. So it's able to set up that initial agreement and keep that agreement valid. Whereas the trust agent, while it can do the user, can see the users and groups and can register systems, it doesn't actually have the ability to manage the trust. So in a small deployment, you don't have to have any trust agents because the trust controller is a trust agent. But in a large environment, you don't have to have every single system or every single IDM system be a trust controller. You can have a bunch of trust agents and just a couple controllers managing your trust. So the requirements for setting up a cross-force trust, we have to, one very important thing is, because we're setting up a new domain, we have to have a completely separate domain. So for example, we'll say we already have an existing ad.example.com. What we would want to do on the Linux side is set up something like ipa.example.com or linux.example.com. The reason for this is because we have those DNS records for Kerberos that are not necessarily like A records, but they're records that just blatantly go out and look for what Kerberos servers do I have, what LDAP servers do I have, and they're records that are probably already populated, will be already populated on your network if you're using Active Directory because they have to be there for Active Directory to work. So if you were on the same network and your Linux system's trying to reach out and find a Kerberos KDC or a LDAP server, it's going to get confused because it doesn't know which system to go to. So we split it out on a separate domain. That's no longer a problem. We have to get firewall ports open. So if there's firewalls segmenting these networks, we have to take care of that. We also have to take care of the host-based firewalls, making sure that things are able to get in and out okay. We have to have a good NTP source, so ideally we want to have a Stratum 1 source, but any source, NIST or any other NTP source will work, and everything has to have different NetBIOS names. So it's pretty simple. We have set up a one-way trust, which means we're going to trust the domain A. We'll assume domain B is our IDM server. Domain A is our Active Directory server. We're going to set up a trust where we trust domain A, which allows users from domain A to be able to authenticate on systems in domain B in our IDM environment. Similarly, a transitive trust allows us to say, if we're over here, domain C is our IDM environment, and we've set up a trust with domain B, well, users in domain A or B will be able to authenticate on domain C by transitive property of having a trust between A and B already in place. Now there is some filtering there that we can set up if we don't want to have access or don't want users from domain A to have access. We can do filtering, but if those trusts exist, we'll be able to see those users and make use of them if we choose to. So the different designs we have here, a basic server topology. This is very simple to what we just talked about with domain A and domain B, where the AD users can authenticate on IDM because of this trust. And then also if we have users defined in IDM, of course those users can be used on our Linux resources. Just another drawing, kind of expanding this out a little bit more. We got our Windows users typically coming in from a Windows desktop or laptop. So they're authenticating here, they get their Kerberos ticket, and then they use whatever SSH client of their choice that supports Kerberos, and then they're able to single sign on to the IDM systems over here. And that's all done because of the trust that exists between our IDM servers and Active Directory that say, hey, we trust your Kerberos tickets and we allow access to you. Also, whenever the Kerberos ticket comes in, it will read from the IDM servers whatever host-based access control rules are in place. So while the user may be valid and have a valid Kerberos ticket, we may have a policy in place that says this user doesn't have access to this system, and we're able to kick them out at that point. All right, so again, we want to make sure everything's unique primary domains. We need to make sure that the necessary DNS records are added. So if we're using some third-party DNS instead of the internal DNS, we have to make sure we have some specific rules in play or specific records in place. We have to run the AD trust setup on the first IDM server just to make sure that the trust is established, and after that we can just set up trust agents from there forward. And there's some stuff we need to do on the AD side that will require us to be AD admin in order to complete the trust. So now we get into groups. With groups, from IDM we're able to see the groups that are in Active Directory, but we can't do anything with them because there's things that are read-only. We can't make any changes to them. So what we have to do is we have to create a group that we want to be able to manage in IDM and then reference that Active Directory group. So you're basically mapping something that you can see, and you can see what the members are of it, to something that you can actually modify and control. And this is useful because, like I said, for our host-based access control and our sudo policies, we have to have groups that we can assign policy to say that group A can get to server group B, but not server group D. So we have the external IDM groups. These are the ones that we're able to see from Active Directory, but we can't really do much with. And then we have our internal POSIX groups. So these are the groups that we create in IDM. And then we build the references from those POSIX groups to the Active Directory groups. So a quick walkthrough. We'll go over the architecture here real quick. Again, the separate domains, I can't harp on this enough. If you try and do this install and it's on the same domain, you will have problems and possibly break what you already have in place. We utilize the Microsoft Privileged Account Certificate. This contains the SID or the security identifiers. And SSSD and IDM are involved to help associate the users and groups and permissions for the policies and getting all those mapped groups taken care of. All right, so to the authentication walkthrough now. So we have our user that's come in from their Windows laptop. They already have a valid Kerberos ticket. They log into the IDM client, and that sends out a request to the trust agent, which goes over to the domain AD domain controller, where we verify the ticket, the Kerberos ticket, comes back down through, checks for host-based access control rules, sudo policies, whatever they're trying to do, make sure everything's valid, and then the authentication is successful. It's pretty simple. Looking at it from this level, can definitely get a lot more in the weeds whenever you're actually on the keyboard working with Kerberos and trying to diagnose why something did or didn't work. So some different deployment scenarios. We'll go over some planning first. Again, our considerations are going to be our size of the deployment, how much we expect it to grow, any kind of compliance policies we have. So FIPS is a big one, especially for federal customers. And IDM does support FIPS mode. We just have to make sure we do that up front, because if we want to enable it later, we have to rebuild. Cost is another big one. There's a lot of technologies out there to help bridge this gap, but they cost a lot of money. These solutions cost nothing. If you have RHEL or you have CentOS already in your shop, you've got what you need. The number of staff and the organizational structure plays a big factor in this. If you got a lot of people sitting around doing nothing, well, maybe doing everything individual systems is okay. But if you don't have a lot of people, you need to streamline things, make it really efficient. So, for some of our general case studies here, client number one, their information is that they have a large AD environment, like we've talked about. They probably have a lot of Linux or a lot of Windows desktops, laptops, and they've got a small RHEL footprint that they're expecting to grow. So they've just started dabbling in Linux. They haven't really, jumped all in, but they expect to have a lot more growth over the next few years. They got a small team of Linux administrators and a small budget, and they require a solution as soon as possible. So, what do you think the best solution is here? What we think would be the best solution here, because of the size of the environment and the time that they need it and the level of expertise in-house, we would use direct integration, because we're able to just take the small amount of systems they have and directly connect them to Active Directory, instead of having to bring any new tools in the environment that are admins that are already probably overworked don't have time to learn. Client 2 has a large AD footprint again. They already have a lot of RHEL machines. They're planning to, or they only have the one domain. Some recommendations for them: we can do the cross-forest trust, but we have to create a new domain for IDM. And there's some other things we can do here where we can migrate some of the systems over time as they start doing some rip and rebuild of putting newer systems in. We can migrate those over to the new domain to get all of the features. But due to the size of the environment and the fact that they're still growing, an IDM solution with a trust would be more appropriate here. So things to consider after we do the installation: there's some configuration or some customizations we can do at the client level, such as the default domain suffix. Out of the box, whenever you set up this trust, you won't be able to just type in your username and password. You have to type in your username with an @ and then the domain of the domain you're trying to log into. So your username @ your Windows domain. But if you're only using users from Active Directory, we can simplify that. We set this default domain suffix, and then it assumes that if you just give a short username, that it's from that domain. We also have offline credential expiration. So if you have systems that are always connected and you want them, if they go offline because somebody has stolen it from the building or something, if you want to make sure that they can't log into it with any cached credentials, you'd want to set this to where everything's always expired. Now, for a laptop or something somebody may take home, you may want to cache their credentials so they can log in when they get home when they're off the network. We can also override the home directory. I mentioned earlier we can do auto mount rules. So here we can set the home directory to an alternate location instead of the default location, so that we can have it set up to an auto mount. Some of the post setup verification that we can do a IPA trust show. What this is going to do is just list out a bunch of information about the trust, the status of it, when it was configured, etc. We can test a Kerberos authentication. So with this, what we would do is just do a kinit and then space the username @ the domain. This will generate a Kerberos ticket if it's successful, and you can look at that by doing a K-list, and you'll see something similar to this. This is your ticket granting ticket that you get whenever you do the kinit. If you don't get this, then that means there's something not right with Kerberos. But if it is successful, what you'll see when you do the KINIT, you'll get prompted for a password, and you immediately drop back to the prompt. If it's unsuccessful, then it complains and says you have issues. You can then test login to a client, so SSH from one system to another, make sure everything works. But keep in mind, when you're doing this, we have to also consider our host-based access control rules and make sure that those are set up correctly. And then, obviously, if we already have a Kerberos ticket because we did a KINIT, we can then test SSO or single sign-on by SSHing to the next system. Note, to do this, though, you have to use the fully qualified domain of the system you're planning to go to. Otherwise, it doesn't resolve the host name correctly for the Kerberos authentication. So, troubleshooting. Where do we go when things break? Because inevitably it happens. We have logs on client for SSSD. Also, we log some of these errors in varlog secure. So if you have failed authentications, varlog secure is a good place to look. We can increase the logging level for SSSD by modifying the debug_level in sssd.conf, etc sssd ssd.conf. We can attempt auth using debug or trace for the KINIT command, and what this will do is it'll give trace level at the command line, so directly in your standard out. And there's also Kerberos logs in varlog krb5kdc.log. On the server side, we can enable debug with debug equal true in etsyipa default.conf. Of course, this is going to really kick up your log level on a lot of things, so I wouldn't recommend leaving that on for very long. And we have our directory server logs at varlog dirserv slapd, the name of the realm, and then the errors log. So some common issues that we've ran into. DNS resolution. DNS resolution is huge. It is hugely critical for this to work. If we don't have DNS, then your client system is not going to be able to communicate with our domain controller, so you're not going to be able to see the users. You're not going to be able to get any kind of Kerberos ticket. If it's even a record that you have records for the IDM servers, so we can go out and see the users, but you don't have a record in there for the client, then Kerberos isn't going to work because it can't grant a ticket because it doesn't know who the client is. So we want to ensure that all systems have properly configured host files and resolve.conf files. Our host files, of course, are going to be mainly just so we have local host references, not really so that we use that in place of DNS. And then resolve.conf needs to point to one or multiple of our IDM servers just to make sure that we have some resilience there if we have one go down for maintenance or an issue. We want to test the resolution at CLI if we have issues using tools like dig or NSLOOKUP, or even the host command. Any of these tools that are designed to query DNS and make sure our rules are in place or our records are in place. Another common issue is time sync. Time being skewed only by a few minutes will break Kerberos because it wants things to be all in the same place at the same time, and if time is skewed, then it assumes that there's something not right in the world and refuses to authenticate you. So time sync is very critical. That's why we include NTP as part of IDM. So we typically set up NTP with NTPD, or on RHEL 7 variants, Fedora, we have cronny. We can verify the time is in sync with the date command. Fairly simple. Just run date on two different systems. If there's a variance of more than a few seconds, then you probably have a problem. You need to go out and make sure cronny or NTPD is running. Another common issue is host-based access control rules, or HBAC. It's not that the HBAC itself is a problem, but sometimes we don't get the rules right. So what we can do there is a test utility that works both from the UI and from the command line in IDM that allows us to go in and define our host-based access control rules, and then we can go to this utility, select a user, select what system they're trying to log into, what they're trying to do. So if they're trying to use sudo, or if they're just trying to log into the via SSH, or they're trying to log in via GNOME, we can select what we want to do there, and then we select the policy, or we can select all active policies and hit test, and it will give us a pass-fail. And that lets you know if your rule was defined correctly, because you can see if the rule passed. So, if you were intended to give someone access to something, you can make sure that it successfully did that. Or if you're trying to remove access from somebody somewhere, then you can make sure it has done that correctly. And if that test passes, then you have an issue, maybe more with Kerberos or something on the client level and not at the server level. So these can get a little tricky to set up, but we have a utility there to help define those rules. Finally, some smart card integration. I'm not sure how many people in here really are too interested about this, so we're just going to breeze over it real quick. Smart card integration, we can do it with direct integration with 7.3 and newer. So RHEL 7.3 or newer, CentOS 7.3 and newer. I'm not sure what version specifically of Fedora that would hit, but yeah, so indirect integration, which is where we're using IDM or free IPA in the middle and setting up the trust. Our clients can be RHEL 6.8 or newer, or 7.2 and newer. And this is just because with IDM being in the middle, it kind of changes the way we do things a little bit. We're able to do things a little bit different way, so we can support some older clients. With RHEL 7.4 and newer, we're able to do certificate mapping, which if anybody in here has done anything with smart cards and Active Directory, this is how you typically do smart card on Windows workstations or Windows Active Directory. You're not actually putting the certificate in Active Directory, you're matching a email address or some identifier on the cert, and you verify that whenever the card is inserted in the client. We can do the same thing with RHEL starting in 7.4 and newer. The one thing to note here is that so this keeps us from having to upload the certs, but this only works whenever we're doing GUI-based authentication. SSH itself doesn't support X509 certificates, so we have to do things a little bit different for SSH. But if you're using if you're using Linux desktops, workstations, laptops, whatever, if you're using GNOME, you can make use of this certificate mapping to avoid having to upload a cert for every single user. Back to the SSH access. SSH daemon does not support X509 certificates. This is something that's been requested to the SSH community several times, but they are very apprehensive to implement it because it obviously opens them up to a lot more threat by integrating SSL certificates into their authentication. So what we do here instead is we utilize Kerberos SSO with GSS API. So we're using that SSO that Kerberos provides to get from one system to the next. So on our Windows workstations, if we're talking smart card with an indirect integration, what we typically see is user comes in, they log into their Windows computer, they get a Kerberos ticket when they log in. Then we use an SSH client that allows GSS API, and you're able to use that Kerberos ticket to then get into whatever Linux resource you need. So for that secondary access, you have used the same credentials that you use to log into the Windows workstation, and thus everything is being controlled by the smart card. We can also, if we don't have the ability to do Kerberos SSO, we can actually dump the entire certificate into IDM, but that's very painful to manage. But it is possible if we have to do it that way. So, some resources and information. We have a Windows integration guide. It's part of the RHEL docs. We also have a blog specifically aimed at Red Hat Enterprise Linux. One Well, we have several people that contribute to the IDM stuff, but you can use the tag IDM, and that will bring up most of the articles that are related specifically to identity management or Active Directory integrations. And then, of course, if you need some help with any of this, you can have somebody like myself come out and help you with Red Hat Consulting Services. And with that, I thank you and enjoy lunch.